Okay, so going on with animation, we're going to be looking at another scene, and this time a lot more complex scene, and sort of look at some other methods of doing optimized, or how do you really optimize animation for something of this scale. If we look at this scene, we'll see that basically we have, let's see, about 780,000 polygons, so faces, which is quite a bit. This, obviously not quite to a million, but it's quite a bit. And if let's look at it in shaded view, and you'll see it is basically this very, very dense sort of cityscape-looking thing. And what I've done for this particular camera move is the following. So let's look at it through the camera. Sorry, it takes a while to update. And we'll see it's kind of just a slowly moving camera, and we'll try to see if we can update it as we go along here. Yep, and we start to go down into the city, into more detailed areas looking in the city, and sort of go down between the buildings and get very close to some of these buildings. So just strategically speaking, let's go back into perspective here and in wireframe. Strategically speaking, doing a baking the way we did it in the last one, where we're sort of baking it from different positions, isn't going to work. We need detail down in here and everywhere. And based on this camera move, we actually need to make sure we get detail where the camera is going. And of course that makes the most sense, and that's the most optimal way to go. So that's kind of what we're going to be learning to do, is just sort of how to sort of optimize your data set along your camera path. And it's very simple to do that, actually. But before we get into that, let's again examine what we have in our scene. We've got the city, we've got a ground. City has a bit of a slight dingy tone to it. I figured I'd give it some life. And ground is fairly dark gray. And then we also have our HDR that we like to use. This is the one again from the Dash library, and the one that's done with very high resolution and very dense HDR. And we're also going to use again another sun area light that I like to use in these areas. And one key thing I think I'm going to do about this area light, actually, let's see if we can find everything in this scene here. There it is. One key thing I'm going to do about this area light is I'm going to place it fairly far away so I get not that sharp a shadow. And I'm also going to do bake in the light. Remember, we had that option to do that. And I want to sort of point that out. That is not necessarily your best solution for this. You're going to want to do, when you're doing animations, you're not going to really want to bake into light in situations like this, because you can get artifacts you're not going to get the best shadows, et cetera, et cetera. So usually when you're doing animations, I would recommend actually in general not to bake into light unless you're doing interior scenes or things where the light only has a small influence, and that's generally okay. But let's sort of, to get back into that, I'm only baking in the light because it really helps illustrate some of the points that I'm doing in terms of sampling and everything else. So normally you wouldn't do this, but for this particular example we're going to do it, and we're going to show off some of the concepts of sampling along this path. Okay, so now that we've figured out our scene, let's look at our rendering settings. And we're going to go back into here, and we've got the Quasi-Monte Carlo sampling, and I'm doing the Mitchell Netravalle anti-aliasing filter. Indirect lighting, same thing. Radiance map Quasi-Monte Carlo, I'm sort of sticking with that for these. And our 3 bounces of light, by the way. No caustics. Environment, I'm going to be doing my HDR as I stated. And for my irradiance map, I'm doing a high and then 20/20. So I know that 20 will not be perfectly smooth, will not be as good, but because I'm baking in the light, it's probably going to be sufficient for there not to be any perceivable noise really, but still be able to get good, decent rendering times. So here's kind of the deal, and here's how we're going to do this. let's go back into our camera view. And if what we're going to be doing is basically the following. As we move along here, we're going to be continuing to capture more and more information. So if we move along in this direction and we sort of look at what the camera's seeing, we want to continue to capture more and more HDRs. So, but you don't want to do it as you're doing every frame. That would just be too much and too overkill. But let's start off by doing it every 30 frames, and this is how you basically do this. So if you go into your render dialog, you go in here, and there's an option here. We're in a single frame. There's an option here to do multi-frame incremental. All right, and as we do the multi-frame incremental, we can select it to basically add as it's going along in the animation. So what you want to do is then go into your frame range and select every nth frame, and I'm going to select every 30 frames. And once you've done that, it's going to continue to collect samples as we're going along. So the next thing you're going to do is, as you remember, you go into the global switches and make sure you do not render final image. We don't care about the final image. We only care about the actual process of the irradiance map collection. And then the other thing you can do is you can do this autosave, and you actually can select where you want to save it and what you want to call it. So let's go ahead and do that. And what we do is just hit this browse, and I'm actually going to go here and go call it camera 1 and every 30 frames via 1, etc. So we go ahead and do that, and we will, next thing we do is we go to our global switches, make sure that's off, and always double check your work. And then we are going to go ahead and render. Now here's the deal about this. You cannot actually save or do this on a network. You have to sort of do it on one computer that incrementally adds the map, because it keeps the data and it just keeps adding the map as we go along. However, we will notice a few other things about it. I'm going to go ahead and do this, and we can look at the irradiance map through the IR viewer when we get back. All right, so I've actually gone ahead and rendered that, and just to give you some details about it, it took 40 minutes to render the entire 30 frames, and since this is 300 frames, every 30 frames, so it's 300 frames, it did actually 11 renders over 40 minutes. Another thing to note is that the first frame took 9 minutes, and then as we were going along, it took less and less time. 9 minutes, I think the next one took 7 minutes, and then after went down to 3, 2, and then a couple minutes for every other frame after that. Now, here is the problem with looking at this data set. This is a huge data set now. If we actually look at the properties of it, we'll see that it's basically got almost 500,000 samples, and it's pretty large, and it's almost impossible to actually see where the relevant information is. It's almost impossible to sort of use this in any functional way when we're actually looking at it. We do notice that we do properly have denser areas where our camera has gone, which is great. But it's really kind of hard to predict where there's going to be holes along our camera. And that's kind of a problem. So what we can do is we basically can sort of spot test this. It makes this, the radiance map viewer that I'm using here is really kind of useful for simple scenes and actually interior scenes as well, because interior scenes you can sort of go into tight spaces. But when you're dealing with large areas like this, it's almost impossible to tell where our holes are, and etc. So what you can do is you sort of know that basically your animation is every 30 frames, or it's collected every 30 frames. So you know that this is going to be a good sample, and you know that this is going to be a good sample, but you don't know about this area here, right? So let's go ahead and spot test that. So for example, I will go into my irradiance map, and I'm going to go ahead and do the irradiance map, and I'm going to do from file, and I'm going to browse, and I'm going to collect that map right there. So I'm going to go ahead and do that. And after I do that, I'll make sure to turn off, go back to single frame. I don't want to save anything. And then also go to my global switches and make sure to actually render the actual image. So let's go ahead and just do a spot test of this. And we'll go through there. I'm actually going to pause the video. All right, and basically here we go, and it's rendered it in 2 minutes and 30 seconds, and that's a very dense scene with all the complex shadows and everything else. So that's a really good rendering time for something this dense and having all the GI baked in. But we have all the GI baked in, and as I said, we also have all these shadows baked in. So it looks like we haven't really missed a hole on this one, but obviously there's going to be some other problem areas. So let's look at those areas and see what they are. If we go to, for example, I kind of actually know where there are some problem areas. If we go to frame, let's say 260, which is between our samples, yeah, about 260 is fine. Let's go there. And we actually do a rendering here. You will notice that we have an issue. So I'm going to go ahead and pause it again. And we look at this and we see that we got all this problem area and all this stuff going on here, and the shadows are not dense. Now keep in mind, like I said, I'm baking in the shadows because it really helps show these problem zones, but you wouldn't normally bake the shadows, so the shadow would actually be sharp here, but it would take longer to render, right? So we're at 58 seconds to render this. Well, it's not a great view, but it's definitely illustrating the problem that we have in terms of everything that's going on. We have to sort of try to get this denser. And like I said, we had 40 minutes to do every 30 frames. And what if we did every 10th frame, which was probably the more logical way to go here? If we did every 10th frame, would it be 3 times longer? Well, let's do the test. And what we're going to do is we're going to do this again. And we're going to go back into our settings here. We're going to go to the segment of 0 to 30, 0 to 300, and do every 10th frame. Go back into our global switches, do not render to render. Go back to our radiance map, do multi-frame incremental, and then here we're going to do every 10th frame. And we're going to go ahead and save that and make sure the autosave is on. Autosave is kind of a great option. It just saves it at the end of the render. And then the last thing we're going to do is, that's it. So let's go ahead and render this, and we can look at the results. So let's do that. All right, and we're back. So what we're going to do now is we're going to sort of, well, let me tell you about the scene first. Yes, it took 72 minutes to record that. Again, 40 minutes to 72 minutes. The reason it didn't triple in time, in fact, it only took, little less than twice the amount of time, is because we're using this multi-frame incremental. And when we do multi-frame incremental, what we're actually doing is a smart, it collects as it's going along, but if it already knows of an area that has samples, it doesn't collect as much. So it's actually going a lot faster between those frames because it already knows of areas, because we're getting closer to between areas. When we're jumping 30 frames, we're sort of jumping geographically very large, and so it needs to almost collect all the samples every time. But when we're jumping only every 10th frame, we're sort of overlapping the zones correctly, so it's not collecting as much. So it only takes 72 minutes to do it, which is pretty good to be able to collect 300 frame animation to do all the Arrhenius map and just do it all in 72 minutes. So I'm pretty happy with what that takes to do that. So let's go ahead and read it from the map. And what we're going to do is just go in here and do browse. Actually, a good way to see how dense your samples are is just literally to see how big that file is. And if we go to details, we'll see that basically we went from 47 megs to 76 megs. So that's a much denser file. Actually, it almost looks like the same amount of time that it took. Anyway, we're going to go ahead and select that one. And we're back at our frame 260, so we can go ahead and spot test that and see if it worked out. So I'm going to go ahead and do that. And let's see, go back to single frame. And we have to go in here and make sure we turn that off. And I think that's it. So we can go ahead and render this. And I'm going to pause the video. And we go ahead and render it, and we see that basically our shadows are nice and sharp. We're not having any problems. This is just kind of all worked itself out really nicely. Rendering time's about 1 minute, 10 seconds. And of course, it does delay a little bit because it has to load that 76 meg file for every frame to be able, because it's basically like a map, or think of it like a shadow map almost. So it has to load that, but nonetheless, it's in pretty good shape. Now we also know that we're at frame 260, and that's actually a frame that it actually collected at, as opposed to the other one where it didn't. But now to find bad frames, we have to go between every fifth, and it's very unlikely that we have some bad areas. So generally speaking, think about it, the speed of your camera and everything else, and think about how much space you need to overlap between frames to get a good sample collection. So what we're going to do now is we're actually going to go ahead and render a full animation of this, and I'm going to load that into the RAM player, and then we can take a look at it. So how we're going to do that is we've got the same settings, and then we're going to obviously going to go into here, and I'm going to make sure I render the whole thing, every frame. Next thing I'm going to do is make sure obviously that's off. And then this is set to from file. I'm also going to add motion blur. We're going to go ahead and just add motion blur, half frame motion blur, or shutter of 180 if you want to think of it that way, and just go ahead and render the animation. And I've actually gone ahead and done that. So why don't I just load that up in the RAM player and show you guys the result. All right, so I've gone ahead and loaded it, and 300 frames at VidRes. Let me give you some ideas of this. At this zone here, basically, it was taking about 5 minutes a frame to render at this resolution, which is VidRes 720 by 486. And then when we were going into our city, so here we go, we can sort of slowly scrub. Again, I urge you guys to play it on the video that's available on this DVD to see the full effect, but I'm sort of just slowly scrubbing through it. As we go through here, we see our motion blur is looking good. It's sped up quite a bit as we get inside the city, because we're not looking at that much of the city anymore. We're a more closed area of the city. And this is about 2 minutes a frame, and by the end here, we're at about 1 minute a frame. So really good, and generally speaking, it looks like we don't really have any real problems as I sort of go through this entire thing here. I can see that basically the entire animation looks fairly smooth, and that we don't really have any problems. However, I just stopped here at frame 276, and I know that's between frames, and I can see a small problem right here. Real small problem. So how do I solve that? Well, if it's a real problem and you need to redo this, you can basically do the following. You can go in here, and as you get through these, you'll sort of anticipate. I already knew that basically there was going to be a problem coming around corners, because this is a whip pan, and I'm basically changing very quickly. And unless I have this covered, I never know if I'm going to actually be able to capture that, because it could go capture here, capture there, and it missed that spot, which is exactly what it did. So what I have to do is I can do the following. If I want to be able to, if this is a problem, I can actually go in there and just do a render of that and merge it in with the other one like we did on our last chapter. So those are good ways to sort of just, collect little problem areas there, and you just merge it in and go ahead and re-render those zones, and that'll be fine. All right, so generally speaking, pretty good, including motion blur, this many samples, full global illumination, HDR. We're able to get it down to anywhere from 5 to 1 minute a frame at VidRes. So definitely shows that animation is possible when we're doing global illumination with all the bells and whistles. So let's go ahead and do this again, and do it with our more complex freeway scene that we've done in the past. So that's going to be the next part of this, is we're going to look at the freeway scene and do it again. All right, so we're back to our freeway scene, and what we're looking at here is the same scene, and the lighting scheme I'm going to use is the original one for this particular test. I'm going to use the one with the sunset sort of light coming through. And a few things I'm going to note about it. One is if you go to the material editor, you will notice that I have the specular reflections. I turned off use interpolation. There's a key reason for that. Use interpolation works great as sort of getting a fast blurry reflection that looks fairly smooth with no grain, etc. But it doesn't work very well at all for animations. The reason being that use interpolation sort of bakes it into the irradiance map, and this will not be baked into irradiance map. And reflections cannot be baked in. Only diffuse lighting can be baked in. So keep that in mind. So it'll still go through the process, but only doing reflections. However, it will not look right. They tend to swim really badly and they just don't look right. So it's much better when you're doing animations to just go ahead and do it in brute force. So I turn it off for all of this. And I also turned off the saved save light. As you remember in our last example that we did with our city, we didn't want to actually burn the light shadows into this. So if I select my light, you will notice that basically I turned off store with irradiance map. I didn't want that on. Okay, that's usually what you want to do when you're doing animation, so we're going to keep that in mind. So with that being said, we're going to go back to our renderings, and everything on this is kind of the same. I've got my 720 by 46. I'm going to do a vidres. Same settings as everything else. The only big difference I'm going to have here is I'm going to go in here and I'm going to do incremental add to current map. I have it on 2020 medium for this particular example, and then I'm going to do actually a segment, and I'm going to do every 10th frame, and I know that this is going to give me the result I want. Also, I'm going to just go ahead and do it in the autosave. And just go from there. There's really nothing else I've done. Actually, well, remember, don't render final image. That's going to be my advantage. And the frame buffer, actually leave that as is. So everything else is just fine. I'm just going to go ahead and render this. And we can look, basically all we're going to get is the irradiance map. So we're going to go ahead and do that. Okay, so it's actually gone ahead and done it. So what I'm going to do is it took about 40 minutes to render the entire process from every 10th frame. It's 100 frames, so 10 images. Again, it went, first frame was about 9 minutes, and then it kept going faster and faster as we went along. So that's a great advantage there. And I'm going to go ahead and read it from file, and I wrote it out here. So I'm just going to go ahead and read out this mesh file. And we can do a few spot checks if you want. So let me go ahead and check that. Just going to try to turn off these certain settings here. Go up here and go back to single frame. Okay, so let's look at a few key frames here. Let's look at this first frame right around here. Let's see what we got. Going to go ahead and render, and then we can see the time at the end there. All right, so it's gone ahead and rendered it, and you can see render time of 2 minutes 53, and that's with the full no interpolated reflections and shadows are not embedded in or anything. So it's pretty good rendering time, generally speaking, for this process. So we're going to go ahead and render this whole thing. But we're going to add a few more bells and whistles, obviously. What we're going to do is, since we're going to go ahead and do this, I'm going to go ahead and turn on motion blur. And so motion blur, same deal, half frame or 180 degrees, depending on how you like to look at it. And we're just, that's all we have to do. So, okay. Next thing I'm going to do is just make sure I've got the full frame range, and I've actually gone ahead and rendered it. So what I'm going to do is I'm going to load up those frames and show them to you, and we can talk about the animation in general. So I'm going to go ahead and do that. All right, again, I urge you to actually see the full animation that's available on this DVD, so you can see it fully animated instead of me just scrubbing through it here. But let's just kind of look at this, and you can see that motion blur is looking pretty good, animations are looking pretty good, and we come down here and it looks pretty good. There's a few issues which I'm about to talk about, but generally speaking, this rendered out fairly well. The rendering times on it were generally around, in this area, probably about 3.5 minutes to 8 minutes here. The big issue I have, and you can see it in this zone and in here, is noise. There's definitely a noise problem. And that's mainly because we have our reflections and our shadows set up fairly low. Actually, our shadows look like they're fine. I'd say the main issue comes down to reflections. So because our rendering times are fairly low for something like this, we could pump that up. And what I would do is I would go in here and I would raise that value. So since I'm going to do another version of this on another lighting scene, we're going to try that out on that next scene and see if it comes out better. But generally speaking, as you can see, I'm pretty happy with this scene. It's going to look great when it's done. It can be done at higher resolutions or whatever. So pretty good success. And now let's look at this using another lighting scheme. All right, so this is going to be our afternoon sun scheme, basically where the bright sun hitting and bouncing around inside that we saw. This was the first alternate that we saw on the previous chapter. And I'm not going to take you through the whole process. We've been through that a couple times already. I'll just say that basically I saved my radiance map every 10th frame. Again, that took about 40 minutes to do that. And then now I'm basically getting ready to render. The quality settings I did change. Here's my sun. And I've changed my subdivisions from I think it was about 8 to 16, and that's going to give me less grain in my shadows. It will increase my rendering time. And the next thing I did is just for the street, I went ahead and I took the subdivisions on the reflections. I bumped it up from 8 to 12. And I think that's going to give me just enough to where I want to be. Another key factor that I did on this is, and this is where it starts to get a little tricky, is I actually, even going up to 12 was not quite getting rid of all the grain and noise that I wanted. And that's because I had I had to sort of play with these quasi-Monte Carlo values here to get it to go away a little bit more. And what I did is I affected the noise threshold. And whenever you're doing, quasi-Monte Carlo effects such as glossiness or shadow glossy or area shadows or even the adaptive quasi-Monte Carlo here, these numbers kind of affect the whole thing. But I kind of pumped it up. I basically said the noise threshold was at 0.005 and it went down to 0.002, basically saying that it's going to try to actually add more samples to lessen the noise and not sort of let those samples go. So that's kind of one last thing I did, and these are kind of some advanced settings that if you start to become more familiar with V-Ray, you'll be able to manipulate. But just to let you know, that's what I did. So all of those things will increase my quality, but will also do a longer rendering time. So instead of going through the entire process, I actually did render this. So I'm going to go ahead and load that into RAM and show you guys the results. So this is actually rendered over at 800 by 600, and lighting looks pretty good. I'm pretty happy with what's going on. So let's go through this and we'll sort of see it. Our motion blur looks good, and our noise has definitely gotten a lot better. I mean, we definitely see much less of a problem in terms of our noise here, and we can really see it when we do here. There's still a little bit left, but not really. The average rendering time for these frames were about 16 minutes a frame, which isn't bad at all. Around this area was 21, and up higher was probably about 8 or something like that. So generally speaking, we were in good shape for our rendering, and very, very much good enough for doing animations and for using GI in production. So hopefully you guys are well covered. Took you through the entire process about GI, the process of doing of how GI works, different methodologies of doing GI. Talked about the concept of the skylight, a radiance map. Then talked about the HDRs and direct light and how all those are affected. Going through a few scenes, taking you through animation processes and all of that. And by now you should have a good understanding of how GI should work for exterior scenes and what's the proper way of lighting exterior scenes with global illumination. So hope you enjoyed this title, and hopefully you'll purchase the next ones.